Today we're going to show you an example pre-construction site. This is a 60-acre high school we're going to be mapping and walking with the 360 camera. We're going to show you everything from getting prepared in the office before getting on the site, as well as actually executing the mission and uploading the data. Let's get into it. Want to find your project here, adjustments in the field, you're able to do so as well. I'm able to click start flight in the bottom right.
As you can see in the top right, has 127, 140. These are all individual photos that are overlapping to create this end result. Now you can look at your elevation and contour line data. And if you select into each of these, you can get the high resolution single photo that was actually taken in that location.
This total mission took 12 minutes and 21 seconds. Once complete, the drone will return home. Now we can move on to the panorama mission, where the drone will take 26 individual photos to stitch into a high-resolution panorama. Next, we're moving on to the photos plan. When you're doing a mission, you can also add and chain multiple missions together. Here, I'll chain the video mission to begin once the photo mission is completed. What's great about the photo mission is that it keeps these photos consistent at the same altitude, as well as same directional focal point every single time. The same goes for the video. You can keep a consistent video from beginning to end throughout the entire project. So, certain times, you may run out of battery while doing missions. You're able to actually do a battery swap. Then, when the battery is swapped, it will turn green and you're able to continue flight. Our last mapping mission is a corridor mission. It is great for road work or any straight areas with multiple bends. Here's an example of the final result of that mission. Now we're going to get into the vertical facade flight portion of the tutorial. Once you hit go, the drone is going to take off at its travel altitude and reach its first point, and then make its way in a grid pattern along the facade. Here you can click into each individual photo. You can create issues as well, which will be viewable in the 3D model. Once you're done with all the missions, get into the office, drop in the SD card data, and the smart uploader will automatically recognize all the types of missions you've flown. Here it will tell you if it's processed with any high accuracy RTK or PPK. Now let's move on to the 360 photo portion. You're going to want to start by turning the 360 camera on and then navigating to your project. I can click capture media. Here I can see where I physically am based off my GPS location. I'm going to want to mark a start point. It'll give me a 5-second countdown into which I can begin walking. I'm going to walk at the pace as if I'm holding a cup of coffee. Walking with the 360 camera is great for getting underside of areas that may not be visible from a drone. Now, once you get to the end of your walk, you're able to hold to end walk. That's gonna stop the recording on the actual camera. Next, I'm able to zoom out and find out where I am, and then I can hold to confirm endpoint. The transfer is complete. When I wanna upload, I will go to view sync list and upload all the walks that I've taken. Here's the end result. You're able to view the walk on top of the satellite map or an aerial map that you've created yourself. So these are the 360s. Let's go look at the web app.
Hi, I'm Trevor Broussard, a senior solutions engineer at DroneDeploy. Now that we've captured images and other types of media, DroneDeploy has processed those images into maps and models and posted. Now we can explore. Below the walk selector, we have our layers. We can bring in various file types from the local device. Commonly, we will see layers brought in from Autodesk or Procore. The most common layer type we see would be a drawing overlay. This can be uploaded as a PNG or a PDF. So typical drawings I see uploaded would be a site plan, maybe a structural drawing, maybe it could be an underground utility drawing. Bring them in, orient them on the site, and you can verify work that's in place, not in place, 2D and 3D visualizations. These can be brought in via DXF or IFC. Also, we support design surfaces. Design surfaces are helpful for analyzing cut fill analysis. This is the map that was generated in DroneDeploy. We can also calibrate the elevation. Let's say that we know a known point on site and we know the elevation. We would like to shift the entire map up or down. We display the elevation layer. We can also refine the histogram and slide the histogram. This is helpful for assessing drainage on site. Maybe we're looking for high spots or low spots. This is the tool I would use. This is how we organize all of the media. Firstly, we organize on the map view, as well as we get more of the album view. We can look at walks. We can turn walks on and off. We can look at panos, photos, videos, vertical inspections, and then also turn on all the map photos. These are the raw images that make up the orthomosaic as well as the model. We also have a markups tab. This is where we can turn off any annotations that were generated in the map and model, as well as issues. Working towards the right side, we can see that I'm an editor on this project. I also have the ability to share, as well as different permission types. I can also share view-only links for the whole project or an individual map. This works really well if we're looking for a month-to-month analysis. Maybe in one map we have trenches that are open, the next map trenches are backfilled, and we're looking for underground utilities. 3D models. You may hear 3D models sometimes referred to as meshes. Let's explore the model. We still have elevation details in the model. We can also display contour lines. We can adjust the major and minor line spacing as well. All of the raw photos are still displayed here in the model view. Same with annotations. On the right side, we can enable auto rotate and adjust the speed. We also have the camera animation feature. All we need to do is add another current position. Now let's start animation. This is the nice way to create essentially a fly-through of the model. I like to use the inspect tool. It can be found by clicking the magnifying glass next to the camera animation. The inspect tool works really well if you're looking for the raw image associated with the map or model. This provides a higher definition image that is not processed into a map or model. Something I like to highlight here is the ability to generate issues within the raw image. Perhaps there's an issue on the tennis courts I would like to highlight to my team. We can select a custom type, perhaps quality, safety, or maybe it's just a note for later follow-up. We can also associate a status, open or closed, a brief summary, as well as the severity level, and possibly a cost to repair. We can also send these issues and observations to Autodesk or Procore. I hit done, and now we can see that this issue lives within the context of the model. I know where the issue is. I can also click into the issue, and I can create comments. Something I like to highlight would be the ability to @mention others that are added to the project. If I do @mention Brian Vizaretta, he will get an email notification directing him to this issue to eliminate some of the back and forth with communication of finding the same issue on site. Eventually, this issue should be closed. And we can also change map and model opacity. This would be helpful if you choose to bring in 3D content as an IFC or 3D DXF. Maybe we're looking to verify installation of underground utilities, and we would like to see through the surface of where these utilities could possibly lie. Changing the model and map opacity would be helpful. Now we're back into the 2D, or sometimes referred to as an orthomosaic. Let's explore some of the other annotation tools that we have access to. Point annotations. These are helpful for conveying the X, Y, and Z, or lat long, northing, easting, and elevation of a location on site. Any of these annotation types, we can create issues out of them. I recommend giving the annotation a name to stay organized. We can also change the color. We have some other annotation types to talk about. The line annotation. Let's demonstrate the accuracy of the line annotation on the football field. So I know that a football field is 100 yards or 300 feet. In DroneDeploy, we are calling the distance of the field without the end zones at 299.82 feet. We display some other information about the line, such as horizontal length, vertical length, surface length, cross-section, slope, and vertical height. We also display the surface profile viewer. You'll see as I move my cursor down the line in the surface profile viewer that there's a node displayed on the line that was drawn on the field to give me an idea of where I am on the field and the elevation. We can display area. We can also draw various shapes such as rectangles and radiuses. I have a rectangle drawn here. We've got 20 yards, or let's see, we've got 29.9 horizontal length and 160.6 horizontal width. I use the circle tool or the radius tool demonstrated here on this baseball or softball field. One way I've seen this used in the past was to demonstrate the pick radius for a tower crane, or really any sort of crane. I know that my crane can pick 100 feet out from the center. So using the radius tool, I can demonstrate the limits my crane can pick from. Any of these annotations, we have the ability to lock. We also have the ability to copy a link. We can also duplicate the annotation as well as delete. From other annotation types, we give you the ability to count. Perhaps we're looking to count stored materials on site for billing purposes. Hit enter once you're done. Now we can see we have 6 items counted. We would like to give it a name and perhaps change the color. We give you the option to create a volume annotation as well. I demonstrated the volume annotation on the pitching mound of this baseball field. The way I found the toe of this pile was I turned on the elevation layer. I refined down to the elevation I'm looking for. Here, let's drop the the point annotation. Around the pile, we can see that the elevation is 112.69. Now we can see precisely where the pitching mound is located. And I just used the volume tool to find the toe of the pile. I know that this pitching mound, there's material volume of 3.72 cubic yards. I also get the area. I get some cut fill stats as well as the net volume. If I wanted to, I can input a material density as well as the cost associated, and we can give you more information of the material in this pile. Selecting the surface type as well as the base plane would be very helpful for accurate volume calculations. You can get more information here by clicking the question mark and clicking on read more to learn more about base planes. We can generate issues just like we did in raw images. We can also generate point or area issues, perhaps for tracking purposes. Change the title, give it a type, a status, a summary, severity, cost to repair. Manage this issue or observation in Autodesk or Procore, or have dialogue with colleagues here within the issue. Looking down to the bottom right, you have options for zooming in and out, as well as rotating the map around. Zooming back out to look at the media gallery, we briefly touched on some of our media types. We have 3 walks, which we will look at. We have 1 pano. I can see 1 pano here in the media gallery, as well as on site. This is the nice 26 frame pano that's stitched together. It's a high definition pano. If we have other panos that were captured in the same rough location, we could compare side by side. We also have options to see who captured the pano and what was the date, delete, renaming the media, and moving the media. We can also download this pano, share a link, and if we had other panos captured in the same rough location, we would have options to view the media gallery for other adjacent panos. All of this media were given the context of the mini map, and now we're going to back out. We also have photos. These are oftentimes used as progress updates, videos, and we have vertical inspections. I can see that there is a vertical inspection icon here at the north face of this building. Vertical inspections work a lot like models in terms of navigation. I typically will use a vertical inspection to visually inspect various components on the exterior of a building, tower, bridge, dam, or similar. I use the inspect tool to find raw images for a higher definition. I use the inspect tool when I'm inspecting the various components on the exterior of a building. I would like to find the raw images. I can use the keys on my keyboard to navigate around and perform visual inspections. If at any point I notice something that I would like to document, I can use the issues tool. Just like we did on the exterior in the maps and models, I can do the same on a facade inspection. This issue will live within the context of the 3D facade scan. Lastly, let's look at some export types. In the bottom left corner of the screen, you'll find the export button. We'll go through some of the most commonly used export types. These are all manual exports, but if we would like to set up auto exports, that's an option as well. PDF maps, GeoTIFF or georeferenced maps. My favorite export type to export a map would be the JPEG map. The reason why is within a JPEG map, I can select the resolution. Some other export types most commonly used would be our point clouds. I particularly like that our point clouds we can decimate. We also have some file type options available. Most commonly I see RCP exports. We also support XYZ as well as LAS. Elevation details. And there's a number of file types that we can export. Commonly I'll see a DXF with contour lines. We also support raw elevation values as a DEM. Digital terrain models, cut fill DSMs, cut fill DTMs. These are helpful for assessing cut fill over time. 3D models, we can export out an OBJ of the 3D model.
And that's a wrap. Catch you on the next one.